Hello. In this video, we're going to talk about inverses of nonlinear functions. So a lot of what we talked about this year have been quadratics and cubics, and we've examined their domains and their ranges, and we're going to continue with that. We're going to kind of build off of that. So up top here we have inverses of nonlinear functions. These have graphs that reflect over the line y equals x. And that's what you see in these illustration graphs, okay? However, not all functions have inverses. So, and we'll talk about that. Sometimes we can create an inverse by restricting the domain of the original function, and that will allow us to build an inverse. So let's see what all this means right here. In this first picture, you see here, first of all, let's kind of build it together here. We have the function f of x is equal to x squared. So we basically have our parent graph of our quadratic, right? Now, we know that this is a function because we know that it passes the vertical line test. So for every one x value, there is one unique y value. But you can see here when I reflect it, if you build some points and you flip the x and y values like we did in the earlier section here, and you reflect this over y equals x, you're going to get this red parabola here. Here's the reflection. Now, this reflection is obviously going to fail the vertical line test. So our inverse is not a function. However, our original function is. So this is what we mean when we say not all functions have an inverse. So the inverse here we say is not a function. And then if we take the second picture here, we have a cubic. So we've got the parent graph, y equals x cubed, or in this case, g of x is equal to x cubed. So we can see our terms, we can see our zero, and again, we can see that we pass the vertical line test. When we reflect this, we switch our x's and y's, we get this illustration. I'm just kind of highlighting it there. And this also passes our vertical line test. So here, the inverse, the red, is a function. And there's a couple different ways that we can work on this. One way that you'll see down the notes a second is, do we need to build the graph and test the vertical line test again? No, not necessarily. There is another test that we're going to talk about called the horizontal line test. And the horizontal line test we can use just like the vertical line test, except we're not testing the function, we are testing the function's inverse. So if a function passes the vertical line test, and it is a function of course, however, if it fails the horizontal line test, we could safely determine that the inverse would not be a function. There's going to be, for one input, there's going to be two outputs. Over here, the blue is going to pass the vertical line test, and it's also going to pass the horizontal line test, which means we could safely say the inverse is a function. Now, to briefly look ahead, the second part here, sometimes if we restrict our domain, now what does that mean? Well, if I go back to this first example, and I take away this half of the original function, meaning I take the function and I say, well, we're only going to work with positive values of x. We're going to say x has to be greater than or equal to 0. So we have 0 and above. So we only have this part of the line, this part of the curve. Well, if I flip that or reflect it over y equals x, that's going to result in just this part. So by restricting the domain, I still pass the vertical line test, and I also pass the horizontal line test. And now the inverse of that restricted function is also a function. And we're going to take a look at that in a couple of examples moving forward. Okay, let's take a look at what we just discussed up above. For example 4, we have a function, and we are asked to find the inverse. So let's just kind of take this apart and do things one step at a time. Let's find the inverse of this function. So if we think back to our steps here, let's take the function and let's replace f of x with y. Now let's flip our x and y values. And let's resolve for y. So I'm going to have x plus 3 is equal to this. I'm going to square root both sides. So I've got positive and negative square root of x plus 3 is equal to y plus 2. And now I'm going to subtract 2 from both sides. So I've got negative 2 plus or minus the square root of x plus 3 is equal to y. And now to end this, I'm going to put this in inverse function form or notation. So I'm going to say my y, or my inverse here, is equal to negative 2 plus or minus the square root of x plus 3. Okay, now for the next part of this, it says graph the function and the inverse function. So I went ahead real quickly and plugged in some values, made a t-chart. I noticed I was in vertex form, so I started with my vertex and I built on the left side and the right side of the axis of symmetry. We're going to discuss this more in depth in class. Okay, now when I look at the function that I graphed, the original function, I notice that the function fails the horizontal line test, which means its inverse is not going to be a function. And that's going to be a problem for the last part of my example here. So what I'm going to do is I'm going to restrict my domain. And I'm going to take away the part of the graph that's failing that vertical line test, a horizontal line test. So I now have restricted my domain. And now I'm going to come back over here and I'm going to say, my original function, I needed to have a domain of all real numbers, comma, and I'm going to want to use x values that go back from negative 2 to infinity. So x is going to be greater than or equal to negative 2. So I put a restriction on my domain such that my graph passes that horizontal line test. Now I'm going to reflect this graph. So to reflect this graph, I'm going to take these 3 points with x values of negative 3, negative 2, and 0, and I'm going to reflect them. So I'm going to say negative 3, negative 2, negative 2, negative 1, 1, and 0. And let me change colors here so we can see the difference. And when I put these points in, negative 3, negative 2, negative 2, negative 1, and 1, 1, 0, here's our reflection. Our reflection also passes now the vertical line test, and if I didn't have that restriction, I'd have that bottom half, and it would fail, it wouldn't be a function. But it passes the vertical line test, so we're good. So now we have our 2 graphs. So let's see, we've got this, we've got the inverse of it. And let's see, determine an appropriate domain for the function, and the given domain and range for the function, the inverse of the function. Okay, so the domain for the given function is all the original, the blue original before I erased it. The domain is all real numbers. But now, for it to have an inverse, we've restricted the domain. And for our, we'll talk about the range. The range now, we go from 1, 2, 3, negative 3 to positive infinity. So our range, all real numbers, y is greater than or equal to 1, 2, 3, negative 3. For our inverse function, we're going to have domain of negative 3 to positive infinity. So all real numbers. X has to be greater than or equal to negative 3. And our range, all real numbers, y is going from negative 2, and this is going to consistently go up forever. So we say y is going to be greater than or equal to negative 2. And now we have all components of this function taken care of, this example taken care of. There's our function. We have them both graphed in blue and red. A domain for the function, and give the domain and range for the function and the inverse function. So there's our domain and there's our range for both, so that we have a function and the inverse is a function as well. So a lot going on in that example. Please just go back, try to follow along. Notice how I just try to take it piece by piece. We can do this math, and I'll show you some shifting in class to kind of get through that a little bit quicker. And there you have it.